Let's do this.
Woo!
Oh. Right? Alright, here we go. We got what? We got what? We paying attention?
Hey, is that the other?
I'm still wondering. I love them. I love
This
them.
logarithms.
I love them. I don't know. They don't listen though, but I love them. I still love them. Okay, can we go now?
Okay,
Is this the other packet?
Huh?
Is this the other packet?
yeah.
This is your, logarithm. You guys ready?
Kowski, use that packet.
Alright, what we want to do, come on, somebody got to turn that headphones down a little bit. 'Cause there's no way you can hear me. Okay? Hey, Zeus, come on, brother. Help a man out. I can hear you more than I can hear myself. Alright,
Where's the logarithm packets?
what?
There's only one more.
We're out. We're out. I'll have to get more.
Do you want me to go make
Can I start yet? Can I?
Yes, you can start.
And then you start.
Yeah.
I'm gonna go make coffee.
Alright. Can I start now?
Yes, you can start.
No.
Dang, man, I swear. Are we ready, Erica?
I am so ready.
Alright, where am I at?
On number 3.
Good. I love them. Alright, here we go. Number 3. We want these to have the same base. So what base are we looking for?
CC and Erica.
So I would break down 243 and go, what does 3 go into 243? How many times?
However many times it goes in.
81. And 3, 27. And 3, 9. And 3, 3. And 3, 1. Right? So this is really 3 to the 1, 2, 3, 4, 5. Right? So this is 1 over 3 to the 5th. Okay? And this is really 1 over, well, how many is in 81? It's 4, right? So it's really 1 over 3 to the 4th. Okay? Now, what I want to ask you is 1 over 3 to the 4th equal to 1 over 3 to the 4th? Is that the same?
Yes.
It is. Because if I do 1 times 1 times 1 times 1 times 1, it's still 1, right?
Yeah.
And if I do 3 times 3 times 3 times 3, it's 81, right? So this is still 1 over 81, right?
Sure.
So I change this to be 1 over 3 to the 4th, right? But it's raised to the 3n plus 1, right? And when we have power of power, we multiply powers, right? We multiply exponents, right?
Of course.
Yeah, of course. So that means it's really 1 over 3 and 4 times 3 and 4 times 1, which is 12n plus 4, right?
Yup.
Okay? And that equals, well, if this is to the 4th, then couldn't this be to the 5th? Right? Dang right. Dang Skippy. Okay? Now here's the cool part. Let me ask you a really quick question.
Go ahead.
5 to the x is equal to 5 to the 6th. What's x?
6.
How do you know that? Because it has to be, right? Because you're saying, hey, 5 to some number equals 5 to the 6th. So it has to be 5 to the 6th, right? So these, because the bases are the same, these have to be equal, right?
Yes.
Alright, well, if these bases are the same, then these have to be equal, right? So then what you have is 12n plus 4 equals 5. Well, that's just algebra. Right? Basic algebra 1. And that's why algebra 1 is so hard. Because everything else is just algebra. Okay? Alright, so I'm going to subtract, not 2, I'm going to subtract 4, right? So I get 12n is equal to 1. So what's n? 112.
So it is 5 to the x and 5 to 6 have a meaning other than just an example.
That's just an example.
Okay, that confuses shit.
This is just an example. It's just saying, hey, if these have to be exact, then that means these have to be exact. That's all. That's all. Does that make sense?
Makes money.
Cool. Next. Well, I'm going to pause it. I think that was a lot. Plus, you guys goofed around for a lot.